So today we are going to see about the rocket science and the space travel to Mars and Moon and outer space and all those things. So let me ask you a question. You have to write in the chat. If you could travel anywhere in space, okay, let it be Mars, let it be Moon or some galaxy far away, where would you like to go? And why would you like to go? Can you write in the chat box? Some people, Milky Way galaxies, moon. I want to walk in the moon. Alpha Centauri. Could the nearest star. Great. So many of you know about Andromeda galaxy, Milky Way galaxy, far off galaxy. So Neptune. Somebody wants to go to the center of sun. Okay, great. So now let's come to this one. There are around Great, your Whirlpool galaxy. So now, if you see, this whole universe consists of 100 billion galaxies, right? And there are some spiral galaxies, there are some irregular galaxies. There are Milky Way is a beautiful galaxy, you know. We'll come to that later, but we have lot of types of different galaxies on in the universe. Let me start with the solar system. Solar system consists of how many planets now? 8 planets. A planet is a spherical body that orbits around the sun. So now we have 4 terrestrial planets and 4 Gasian planets, that is Jovian planets, we call it as. The terrestrial planets, only life can exist, if at all life can exist. So, because these are all made of, the gas planets are made of fully gas. There is no terrestrial, there is no rock planets, rock things available. So, we have Mercury, Venus, Mars, and all those are terrestrial planets. And Jupiter, Saturn, Uranus, and Neptune are all gas planets. So now let's come to the size of the planets. If you see, compared to the Earth, other planets are so small. That much huge is our sun. This is the size of the planets. Now, we have seen beautiful solar eclipse. Why? We are seeing only on Earth we can see. In any other planet, there is nothing like this solar eclipse. Why, you know? Because the moon is 400 times smaller than the sun. And it is also 400 times closer to Earth than the sun is. So because of that, even though you see here, the sun is too huge. But on a solar eclipse day, the sun looks small. It is all because it is just covered by the shadow of the moon, because of this ratio, the moon is 400 times smaller than the sun, and the moon is also 400 times closer to the earth than the sun is. This means that from earth, the moon and sun appears to be roughly the same size because of this ratio. So from earth, when you see, when the sun at particular rotation, it covers completely. So you can see a beautiful solar eclipse. That is possible only on Earth. And people have seen so many planets and stars, but here you have this ratio so beautifully designed. If you see from the Earth, the moon can entirely cover the sun. That's why the sun is totally covered, and you can see a beautiful eclipse here because of this ratio which I explained. So the size of the planets also matters for everything. And here Mercury is 57.91 million kilometer away from the Earth. It is the closest planet to the sun, and it completes an orbit in just 88 days. So now if you see Venus, it is 108.2 million kilometer from the sun. So Mercury is 57.9 million kilometers from the sun. Venus is 108.2 million kilometers. And Venus is almost similar in size to Earth. If Venus size, you can see here, it's almost similar to the Earth. But it has a very poisonous atmosphere. And it is also the hottest planet. Earth is 149.6 million. This is called as 1 Armstrong unit. 149.6 million kilometers is also called as 1 Armstrong unit. It's the only planet so far. People are searching for life so many places. If aliens are there, so many places people are searching. But till now, no other planet has life. Maybe somewhere deep inside they can find. But till now, whatever we search, there is no life elsewhere. So Mars is known as the red planet. It has the largest volcano in the solar system. And coming to the Jovian or the gas planets, Saturn, Uranus, Neptune, and Jupiter, we have Jupiter as the largest planet and has a massive storm called the Great Red Spot that's been raging for centuries. And because Jupiter is at the right place, any asteroid or meteor which is supposed to strike the Earth is first striking the Jupiter because of its huge gravity. So Jupiter is like a protector for us. So Jupiter is the largest planet and it's like a protector and protecting us from asteroids and meteors. And Saturn is 1.43 billion kilometers away from the sun. It's famous for its beautiful rings, and the rings are made of ice and rock. Uranus is 2.87 billion kilometers. It rotates on its side, making it unique among the planets. It rotates differently compared to all the other planets. And Neptune is 4.5 billion kilometers. Now, compared to Mercury, Neptune is so far away. It has the strongest winds in the solar system, huge storms, very powerful winds in the solar system. So now coming to all the planets, distance, if you see here, let's take a scenario. You're driving a car at 100 kilometers per hour. Now you would take 170 years to reach Mars. Now you go to Neptune, you need 5,000 years. So think about it, how you would communicate. So that is why space communication is a challenge beyond Mars or beyond, but still our scientists are working on that. And we have sent Voyager and Voyager 1 and Voyager 2 be in the interstellar region. Let's study about Voyager 1. This Voyager 1 was launched by Carl Sagan in 1977. It is the farthest human-made object in space. It entered interstellar space in August 2012, crossing even the heliopause. That's over how much distance, 160 times the distance between Earth and Sun. If you have X as the distance between Earth and Sun, 160 into X, that is the distance it has gone. Next, they launched Voyager 2 in November 2018. It entered the interstellar space in November 2018. So Voyager 1 entered the interstellar space in August 2012. Voyager 2 entered in November 2018. Both are sending data back to Earth from there. So that is why even after 47 years, we can learn about the universe because still it's working. It takes more than 21 hours for a signal from Voyager 1 to reach the Earth. That's how vast space is. And even our advanced communication systems, we need 21 hours. Both our Voyager 1 and Voyager 2 has a golden record. In that golden record, they have 55 languages, greetings, sounds, images. So they thought that, okay, some alien is encountering the spacecraft. So it has to study about the Earth. So that is why they put the golden record. At that time, some scientists were so much against it. What if some aliens find where we are and come and fight with us? And some people were against sending this golden record. But golden record is in both Voyager 1 and Voyager 2. But till now, it has not encountered any aliens till now.
Ma'am,
Mm.
I have a doubt, ma'am. Suppose one of the voyages start to fail, what happens?
If it fails, then it will stop communicating.
And what if we don't get information? What would the scientists do?
Maybe they will do some other corrections.
Students, I would appreciate if you could hold your questions the last of the session.
Many of you have a lot of questions. I'm so excited that you're so interested. And let's have a lot of time. At the end of the first session, maybe we can have some time and then we can go further. So this is the Milky Way galaxy. Somebody was telling, because this looks so beautiful, spiral galaxy, you want to get into this. So, you know, this Milky Way galaxy, to go from one end to the other, you need 100,000 light years. For example, you are traveling at the speed of light, you need 100,000 years. So here it is, the sun is located here, our solar system. If it is located in the center, or if it is located here, what would happen? I will explain you, but it is located in the inner rim of the Orion arm. So that is the perfect place for the sun's existence. Let me show you. Yeah, here, if the sun is located, right now the sun is located here. If it is in the center, there is a big black hole, not only one. There are few black holes in the center of every galaxy, and it will heat our sun. If it would have been located in the farthest part, there are very few elements. So life cannot exist. So our sun has been designed. I told you about the beautiful design of the solar eclipse. Even the sun's position in the Milky Way is a design, as how somebody has beautifully designed for you to be here. Your life has a purpose. So now this Milky Way is located in a local group. It is, see, this is a local group, and this is the Andromeda galaxy. And this local group has Milky Way, Andromeda galaxy, Triangulum galaxy, so many other galaxies. Milky Way is just a tiny dot here. Now coming to this is the Virgo supercluster. You cannot even see our Milky Way. That much huge this Virgo supercluster is. Now this Virgo supercluster is part of the huge galaxy, huge universe. There are so many galaxies, superclusters out there. So that is a huge universe. So you are living in a huge universe. If you want to go now to different places in this galaxy, it's impossible in our lifetime. So that much huge it is. So we are trying to scratch, like if you see a ocean, you cannot catch all the fish, but you can catch a little one. That's what we are trying to see. Whatever we can find out with in our lifespan, what is possible, that's what we are trying to see. So this design of the universe is so amazing. So now, what is a star? A star is a large celestial body that is composed of gas, and it emits light. And most stars are composed of almost entirely of hydrogen and helium. So here you see, a star also dies. So for this stellar nebula, when it dies, what happens, Um, it is, see here, a massive star, when it dies, it becomes a red supergiant, and then it ends up as a supernova. It bursts, and when the mass is too huge, it ends up as a black hole, otherwise as a neutron star. If the mass is less, it becomes a red giant, then it becomes a white dwarf, a black dwarf. Our sun will become a red giant. It will not become a supernova or a black hole. After 5 billion years, our sun also will die. So, but at that time, it will become a red giant, and after some time, it will become a white dwarf and others. So now, this is the way every star is born. A star is born because of so many, a nebula is created because of the gas and dust, and slowly it becomes a star. And then after some time, it burns for 5 billion or 10 billion years, and then it dies. When it dies, a massive star dies, we can see a beautiful supernova. Like it's like your Diwali crackers. So that's how the supernova is. It's a brilliant explosion in which a star blows itself. And the star is more than 8 times as massive as the sun. It can produce a black hole. So the supernova shines so bright from weeks to months. They increase its luminosity, and after some time, it slowly reduces the shine, and thus it disappears, and then it ends up as a black hole or a neutron star. So let us see when we get a black hole. Black holes are made when a giant star, mostly many times the mass of our sun dies. So most of the star's atmosphere is blown into space as a supernova explosion. That if the mass is more than 3 times the mass of our sun, it will collapse into a supernova. So I wanted to show you something else, but if you scratch, it's impossible. So my dear students, I request you not to scratch. Okay, great. Thank you. So there is one astronaut. Okay, I'm going to tell you a story. His name is Bruce McCandless. He was the one who first took spacewalk to the next level. How many of you like to do spacewalk? See, this is the astronaut who did spacewalk. He walked on space. He floated away almost 100 meters away from the spacecraft. So there was no tethering on him, because normally when astronaut moves away, he gets tethered to the spacecraft. But Bruce McCandless, he just moved away. Why, because he had a backpack with small jets that allowed him to go back to the spacecraft. But when somebody asked him later, how did it feel when you flew away from the spacecraft? He said, everything out there is very cold. And this was very terrifying, the silence out in the space. If somebody puts you in a room and make you to sit there for one day, how would you feel? Silence of the space was terrifying for him. So how you feel, you can write down in the chat. What would you do if you could float freely in space like Bruce? Write in the chat box. So now, what keeps astronauts on a spacewalk in space? What keeps our planets in orbit? Let's study that. So now this astronaut is there on the space, and we have our spacecraft in the space. Why they are not falling down to the Earth? Why it's rotating around the Earth? What makes them to rotate? Why the astronaut is not falling down to the Earth? So let's study that. So please do not scratch. Astronauts on a spacewalk are in low Earth orbit. Okay. So they are almost, gravity is 90% as strong as on Earth. But then also they are looking to be floating, right? This astronaut is floating, but gravity is almost 90% strong there. So why do they float? Because they are in a constant state of free fall. This creates a sense of weightlessness called the microgravity. So all of you know about gravity, right? Gravity is the one that keeps astronauts in orbit, but doesn't pull them to Earth, because the astronauts are already moving in a horizontal speed. Without gravity, they would fly off into space. Somebody has some doubt. And so what you do is you write down your doubts. And then at the end, when we give the question answer sessions, we will look at the questions what you have posted there. So keep writing your doubts on the chat box. If you have any doubt, at once write in the chat box. Okay, great. So now an astronaut, because last time I allowed people to ask questions, then everybody asked parallelly, so we were not able to answer, right? So now I request you to put your questions in the chat box and not to scratch on the screen, because some thing is enabled and I am unable to go further if you scratch. So now gravity keeps the astronauts in orbit, but it doesn't pull them to Earth because the astronauts are already on the horizontal speed. How? There are two forces, gravity and inertia. Inertia is the tendency of an object to remain in motion or at rest. If you are at rest, you will be at rest. If you are in motion, you will be in motion, unless you are acted by an external force. That's why if an astronaut moves away from the spacecraft, he'll be just moving in that same place. He cannot go back to the spacecraft unless he has something called tethers or jets or handholds to control their motion and walk towards the spacecraft. So inertia makes astronauts float freely in the direction of their last movement, unless they actively stop by something. So gravity and inertia, they balance and allow the astronauts to do spacewalk, right? So now you should know about gravity and inertia. These are the two main reasons that a spacecraft is there. Now I'm going to give you an example. This you can do it at your home. Okay, so now take a ball. You have to do it in your home today night. Okay. So take a string and take a ball. Okay, now hold the other end of the string and swing the ball in a circular motion. Now, if you see that the string represents a gravity because the ball is pulled towards your hand. The ball's motion represents inertia. See, now it's going in a circular motion. So now gravity and inertia create this orbit as the ball is constantly pulling inwards while trying to move outwards. So now when you leave your hand, it just goes off. So now because if there is nothing else acting on it, it just keeps moving. So this is the way any astronaut will walk in space, or any spacecraft is rotating around the Earth. So gravity is a force that pulls all orbit objects towards each other. The force of gravity pulls a planet towards the sun. Okay, so now the tendency of an object to stay at rest or in motion along a straight path is called inertia. So now these two forces keep everything in its orbit. Even your moon is there in the orbit because of this particular two forces, the result of the balance. For example, gravity is pulling it inside. I showed you the example of the string and the ball. Inertia is making it to go in the same direction, move in a curved path. So it is continuously going through unless you stop it. That is the first law of Newton's first law of motion. I'm going to explain to you. So what keeps our planet in orbit? So let's go to our planet. Earth, moon, and sun. The moon revolves around the earth, right? The earth revolves around the sun. Why they are not falling on us? Why moon is not falling on us? Because of, again, inertia and gravity. So now it takes Earth around 300 and more than 365 days to complete one revolution around the Earth. That is called as revolution. So revolution occurs as the Earth moves around the sun. So it means technically it's going in an orbital path. So now next let's come to the rotation. So let's compute the speed of rotation at the equator. Circumference of the Earth is 40,000 kilometers. Time for one rotation is 24 hours. So now if you see, speed of rotation is around 40,000 kilometers by 24 hours. So this is the way. So when you're in the Earth, don't think that you're simply sitting. You're all the time in a motion. You're just moving around the Earth. You're rotating. And also one more important thing is this Earth's rotation is the reason that you get day and night. And also you get season because the Earth's axis is tilted by 23.5 degrees centigrade. That's why if you put an imaginary line, this tilt causes the seasons. Summer, winter, spring, and autumn you get because of this tilt. So when the North Pole tilts towards the sun, it's summer in the Northern Hemisphere. When the South Pole tilts towards the sun, it's winter in the Northern Hemisphere. I taught you about revolution, I taught you about rotation, and also the reason for, because of that we get day and night, and because of the tilt we get seasons. And now this inertia, what if the inertia is stronger than gravity? Then the objects would stay on their straight path and fly off into space. If gravity was stronger than inertia, then objects would crash. So what happens, the gravity and inertia work together to keep the moon orbiting around the Earth. Till now, we studied about the universe, we studied about the solar system, we studied about the black holes, we studied about various galaxies. How many of you are ready to get into now aircraft and rockets? Put yes or no. Great. Thank you for so many chat messages are going on. I will look into it. So first time in those days, people wanted to look at the birds, they wanted to fly. And that's why so many gliders and so many people tried to fly. In 1892 to 1897, people were trying and many people were killed. The most significant experimenter was a German glider. His name was Otto Lilienthal. He, between 1891 and 1896, he built and flew a series of highly successful gliders. But one day in 1896, his glider stalled and he was unable to regain control. So from around 15 meters, he fell down, broke his neck and died. So next one, we see Octave. He did an extensive research on how to fly. Unsuccessful attempts at flight, he has everything he documented. So this helped later people like Wright brothers to study that and use this book for taking a flight. So then comes the Wright brothers. There was one person called Samuel Pierpont Langley. So he was asked to do by the US government a flight, and he was given $50 million. And then he had a lot of people under Princeton and Harvard working with him. But this Wright brothers, nowhere away, just 100 miles away from them, they didn't have any money. They had a bicycle shop. They learned about stability and control. They learned about how to have better wings for aerodynamics, how to develop a lightweight system, how to have efficient propulsion. They studied whatever books were available, and they did lot of models. In 1900, they developed this. Then they crashed. 1901, they developed. 1902, then 1903, finally, during the Christmas time, they took off the flight. At that time, no one was there even to look at it, to see that. So now coming to the flight, we have four forces. For any object to fly, we have to overcome gravity. Try to fly and see why you're not able to fly. Because your body is pulled down because of gravity. That's what it's called as weight. So to accelerate an object, now you have to work against this weight. So for an aeroplane, we overcome this weight by creating an opposing force. People are studying about the wings of the birds. So aircraft is designed to have wings like that, and so it can fly. And finally, when you enter into an atmosphere always have a drag. So this drag resists the motion. So now what you are supposed to do, you should have an engine. So aircraft has an engine to give thrust. So now you have a tug of war between lift, drag, thrust, and weight. Remember these four forces: lift, drag, thrust, and weight. If an aircraft is rolling this, it's called as roll. If it is moving this way, it is called as yaw. If it's going up and down, it's called as pitch. So this is roll, this is pitch, and this is yaw. So now let us get into the rocket science. Till now, we studied about the universe, I studied about the stars, we studied about the aircraft. Now we are going to study about the rocket science. So you are excited? Let me see your chat. If I have to answer any questions, remove scratches. Flight design is like a bird, am I right? Yes. People looked at bird and then they started to develop the flight. So what are the other questions you have posted? What is the difference between atmosphere and gravity? Yeah, atmosphere is a blank, is a gas, right? You have a lot of oxygen, nitrogen, and all those things are part of the atmosphere. So the atmosphere creates drag in an aeroplane. So now your gravity also pulls you down because of your weight. Atmosphere also creates drag. So you need to have a thrust by the engine and you need to develop a lift. So thrust and lift works against drag and weight. So rockets don't have wings to create lift like aeroplanes. So how do they do? They should have powerful engines to create thrust and overcome the gravity. They don't have lift because they don't have the engine. So they are designed to minimize drag. Why drag comes? Because of the atmosphere. Now these rockets are designed to minimize the drag because there is no air in space. Once it enters space, there is no drag. So the rocket burns fuel rapidly. So that's why rocket needs a lot of fuel. How much ever you need a power for the rocket, you need to give fuel for the rocket. Because inside the Earth's atmosphere, drag is highest because atmosphere gives drag. That's why you need to overcome drag. So you need to give a powerful engine. So now how many of you have seen rockets? They're falling so many stages falling down one after the other. Why do you think the rockets are designed to shed stages? Because if the heavier the weight, more the fuel, right? So you have to make the rocket lighter. So then only it can use lesser fuel. So that is why rocket is made of many stages and it keeps dropping down the stages as they go on moving forward. So let me tell you once again, rockets don't have wings. That's why they rely on powerful engines. They are designed to minimize drag because there is no air in space. They burn fuel rapidly that because when they are inside the Earth's atmosphere, they need lot of fuel because the drag is highest. In space, there is not much atmosphere, so drag is less. And they have many stages because they want to have a lighter rocket and use lesser fuel. So how many of you have studied about the Newton's three laws? These are the reason for the rocket science. So you should study about the Newton's three laws a lot. So a body in motion, this is the first law we spoke about, inertia. A body in motion remains in motion or a body at rest remains at rest unless acted upon by a force. So it remains there unless acted by a force. This force is mass times acceleration. And for if I hit you, you will hit back, right? For every action, there is an equal and opposite reaction. That is the main thing. So now, example, if rocket has to fly high, you need an opposite direction. Right now, if you have a balloon and you send a balloon out, you open it out. So the balloon is sending the air out, but it's flying high when it is coming because the air is moving down, the balloon can fly high. So the same manner, the thrust, the fuel burning gives the thrust and makes the rocket to go high. So let's come to the Newton's first law of motion. Newton's first law of motion describes what do you know? Can you tell me what is Newton's first law? I'm not going to tell. Can somebody put in the chat? Inertia. You might have forgotten Newton's first law. We spoke about inertia, right? So Newton's first law of motion describes when no force is acting upon it, the rocket is standing on a launch pad, it will stand still. Unless a force is applied to it, then only it will set on motion. What is Newton's second law in the rocket? It describes the heavier an object, the more force is required. If the rocket is heavy, you need more fuel. So that's what it says. And then what about the third law? You can look at this figure. Sorry. For every action, there is a reaction. Yeah, fuel is burning down. That is why the rocket is moving up. The fuel burning is an action and the rocket flying high is a reaction. It applies on the working of, this is the Newton's third law is the most important thing in a law of a rocket. It burns fuel to create a push on the front of the rocket. So this creates an equal and opposite force on the exhaust gas as the exhaust gas is moving backward. As the fuel is burned, the hot gas shoots out. And this is called as jet propulsion. Why you have so many stages? I need so much fuel to take the huge rocket up to moon. But I don't have that much fuel. I don't have that much thrust. So what I will do? So I am going to make the rocket into pieces. So first stage, the solid propellant boosters, what they do is they just take it to a rocket around 28,000 kilometers, that much high speed it takes. And then it goes after going to a little higher, all the gas within 2 minutes, all the fuel is consumed. So it falls down. And then the second stage takes up, third stage takes up. Then the final engine starts its work. And finally, everything gets detached and the final piece enters the area. So this is all about rocket science. I'm going to show you a video of who is the first person who landed on the moon. Can you write on the chat box? So before that, some people have asked, what is inside a black hole? Do we age in space? What is one light year? Okay, good. If somebody can write down all these questions and ask me at the end, that will be great. Written Neil Armstrong. Good. So yeah, I'm going to show you a video about Neil Armstrong right now. Let's start. See, the moon is around 240,000 miles into outer space. So on July 16th, 1969, Apollo 11 carried three astronauts, Neil Armstrong, Buzz Aldrin, and Michael Collins. They launched from Cape Kennedy, Florida. So that there were three stages of the Saturn V. The actual Apollo spacecraft is made of just three parts, but the rocket that launched the Saturn V had five stages. You know that they had and the real spacecraft Apollo had three main stages. The first one is lunar module, service module, and then the final one is command module. Command module is the most important module that returns back to the Earth. So lunar module is the one that enters the moon. The service module is the one that helps in propulsion. So let's see, this is a distance between Earth and the moon. So this is a rocket that took them. So now it has to be made of this so many stages. One first stage, second stage, third stage. So in the second stage itself, we have three stages. That is, as I said, lunar module. This is called the Apollo spacecraft, and the total rocket is Saturn V. So this is called the lunar module, and this is the service module. And then the top one is the command module, where the three astronauts are sitting inside. Okay, so this Apollo spacecraft has three modules. On the top, there's a launch system. So now if anything happens, at least the top portion will be safe. So this Apollo Saturn V now starts with this many stages. So the first stage, after some time, the fuel gets exhausted, first stage launched Apollo around 42 miles above the Earth. And when it reached around 6,000 miles per hour, what happens is it falls down because all its fuel gets exhausted. Then again, stage 2 and stage 3 gets powered, and they take the Apollo spacecraft 103 miles above the Earth's surface, and then they fall down, and they allow the Apollo to enter into the translunar injection. This is translunar injection is going from the Earth's orbit into Moon's orbit. If you want to go from Earth to the moon, you have to go from this Earth orbit into lunar orbit. So that is called translunar injection. So now to access the lunar module, but the lunar module is deep inside to give safety to it. So what happens is the service module comes out, it rotates 180 degree, then it goes back, pulls the lunar modules out, and then throws the other section. And then now this is the only stage that enters the moon. This is all the other stages falls off. After around 3.5 hours, we come to this place. Then they rotate around 3 days. So now what happens there? There are three people, Armstrong, Aldrin, and Collins. Collins stay in the command module, whereas Armstrong and Aldrin gets transferred to the lunar module, which is called as Eagle. So now the Eagle alone lands on the moon. So now from the command module, the lunar module breaks out. So which carries only Armstrong and Aldrin. So whereas Collins is sitting in the command module looking at them. So now they come and walk on the moon. So Armstrong says the first only, it's just a step for a man, but it is a huge step for a mankind. The first time a man has stepped on the moon. Then they return back. When they return back, they use a launcher and get into the command module. From the launch, lunar module falls off. Now the three of them join together in the command module. Now they try to come towards the Earth. So for 2 days, they have to travel back to the Earth. When they travel back to the Earth, what happens is when they reach the Earth's atmosphere, see, you can see here, it is blasting. The heat shield is blasting. And finally, they launch their parachutes and they fall into the Pacific Ocean. And now they are along with the command module, they're taken from the ocean. They come out and they are safe. This is the way we launch spacecrafts. See, we studied about the Apollo. I told you how the Apollo spacecraft launched and it landed Neil Armstrong and Aldrin on the moon. So after so many years later, 50 years have been over. So the next program is Artemis program. So in this one, they wanted to land on moon, the first woman and also a person of color. So from the moon, they want to use it as a groundwork for sending astronauts to Mars. So 2022, they sent Artemis 1, but it was not having any crew. Now Artemis 2 is going to be a crewed flight and it will take humans to the farthest place so that they are going to talk about Artemis 2.
Missions to the moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad east, orbit around the moon, the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal descending from the halo orbit on a multi-day trajectory back towards Earth. As they near the end of this journey, the circ miles per hour at 300 miles per hour.
So this is the Chandrayaan. Chandrayaan made us proud that we have sent, but it is there is no crew in Chandrayaan, but we will send soon. Chandrayaan 3 was launched on 14th July 2023, and it was a successful one. And you can see here, this is a Chandrayaan.
4, 3, 2, 1. We have ignition.
You can see here the orbits are elliptical. That's what somebody was asking me question. You can see like it just makes us orbit like this to enter into the moons. So now this Earth, it has escaped. See, it is escaping and entering into the moon's orbit. I'll show you here. So this is the Earth's orbit. It made so many rotation around the Earth, and now it's escaping and it's coming into the moon's orbit. So moon again, it will rotate for a few times so that at the right place time, the rover Vikram will separate and it will learn on moon. Okay, so let me now, before going to the Mars, I am going to answer some of the questions. Does an aeroplane have a streamlined body? Yes, it has a streamlined body. So it's very, very important to have a streamlined body. Otherwise, you will not develop a lift, right? Somebody has asked, do we age in space? Yes, actually, what happens is slightly different. The process is slightly different due to the effects of microgravity, radiation exposure, time dilation. So muscle and bone loss, this microgravity, what I said that even though 90% of the gravity is there, you are on a free fall. And that is why you have a muscle and bone loss. So they don't use their muscles and bones much. So when you don't use it, you will have into problems. So biologically, they age faster. So fluid redistribution happens. Immune system gets weakened. So that is why they exercise for almost 2 to 3 hours there. They are asked to do exercise like that. So they are also asked, they are also more prone to radiation exposure than us. So because of that, they get cancer, they get cardiovascular disease, cognitive decline, and all those things. Similarly, time dilation. Time moves slightly slower for someone traveling at high speeds compared to someone on Earth. So that's why this effect is known as time dilation, and sometimes it can create some issues. That's what. So that's why some of the astronauts are seen to age little faster compared to those on the Earth. Then what is inside a black hole? I said that inside a black hole, a star bursts when the star's mass is more than 5 times that of our sun. What happens is it becomes a black hole. But it's what is inside a black hole is the most mysterious and fascinating concept, because nobody knows. The center of a black hole may emit tiny amounts of radiation, but what happens is you get crushed. Matter gets crushed inside a black hole. So our understanding of a black hole is not there. What is inside it? Because if you walk towards a black hole, you will get pushed into it. So mysteries of black holes continue to inspire people, and that's why we try to explore more. They just it's a black hole is full of high gravity. Like if something you just go near that, it just pulls you inside. Even light cannot escape the intense gravity. That's what black hole is all about. Then what is 1 light year? Light travels at the speed of 186,000 miles per second. So a light travels with that speed for 1 year. What is that? That is called 1 light year. Okay. So light travels at the speed of 186,000 miles per second. Somebody has written space sciences. Very interesting. So someone has asked how can a huge object can fly? Yes, so this is what people were thinking earlier. How can a huge object fly like an aeroplane? That's what I told you about 4 forces. What are the 4 forces? I taught you: lift, drag, weight, thrust. So you need to have a good wings and aileron and so many other things to develop that lift large wings, powerful engines, lightweight materials, and all these things you need. So that is why you have in a rocket, you need an equal and opposite reaction. So thrust overcomes gravity. So all these things make a huge object to fly. So then what else? Travel. Do someone who had traveled in the speed of light? Nobody can travel in the speed of light. Nobody can travel. Because speed of light is not possible. What are the next questions? Why do penguins live in the North Pole? They do not live in the North Pole. Actually, penguins are native to Southern Hemisphere because it offers them a predator-free environment, lot of food, a good condition for reproduction. So polar bears is the one they live in the North Pole. Penguins live in this Antarctica. So you should remember that. Polar bear live in the North Pole and penguins in the South Pole. One is in the Arctic and the other one is in the Antarctic. So, ma'am, there is no oxygen in space. Am I right? How the sun is burning? So sun is not burning because of oxygen, right? Oxygen is needed for you to live. If oxygen is not there, you cannot live. But how does the sun burns? Sun burns not in the way we think of like earth, like wood or gas burning. If you want a wood to burn, what you should do? You should put some fire on that and it will burn. But sun doesn't burn because of that. There is something called a nuclear fusion. So nuclear fusion is a process where hydrogen atoms fuse together to form helium. And when this happens, it releases a huge amount of energy. This fusion happens in the sun's core. This is called a nuclear fusion. Remember, this is made of hydrogen atoms when they fuse to become helium. So the temperature becomes around more than 15 million degrees Celsius, and then the pressure becomes so high. And that is why it burns. The sun is mostly made of hydrogen gas. So because of the extreme heat and pressure, this triggers a chain reaction, and that is how it powers the sun. How can rocket travel so far? This I have answered. The main engine creators are, Elon Musk has a company called SpaceX. All of you would have known about the SpaceX. And SpaceX does it. And one more company equivalent to that is called as Blue Origin. They also do a lot of rocket engines. And there is one jet propulsion laboratory in Pasadena, US. They also do it. So Rocket Lab, so many other companies do. I have a YouTube channel. You can search in my name called Latha Christie. And I have put some of the videos there. So you can go through that videos and check it up also. So where will the rocket parts fall? They fall into ocean. But recently, Elon Musk has done something, the rocket, when it is powered, it doesn't fall into the ocean. It comes back and attaches to the same place. So he could retrieve that things back. So that is the latest one advance they have done. Earlier, it used to fall into the ocean, but recently one of the rocket, it comes back and just fits into the same module where it started from. So that is something amazing. Recently, they have developed that. Artemis and Apollo are Greek gods. Yes. So they use the Greek gods to give names. So we give Chandrayaan, Mangalyaan, like we give in a different way, whereas each country gives names in a different way. So what the astronauts get burnt due to the gravity while coming back. See, that is why you have a heat shield. Whenever the spacecraft enters into the Earth on a re-entry time, you have a heat shield, and because of that heat shield, they don't get burnt. See, Chandrayaan-2, somebody has asked, is it failed or what happened, Chandrayaan-2? I would say like it's partly failed. I won't say it's a fully failed because it was launched in July 22, 2019. It was launched to explore the polar region. And what went wrong is there is a Vikram lander. I told you about the lander. It began its descent to the lunar surface on September 6, 2019. During the final descent, around an altitude of around 2.1 kilometer, that lander has lost communication. So, but till that time, it went very well. So, and they wanted to deploy the Vikram lander and Pragyan rover for scientific thing. So that is why mainly they are thinking the reason for failure is a software glitch could have happened, like they are thinking. But it is partially only failed because despite the failure of the lander, the Chandrayaan-2 remains operational, continues to perform valuable scientific observations like high resolution mapping of the moon surface and others. So Chandrayaan-2 matters because it demonstrated India's growing capability in space exploration. So we cannot tell that somebody has returned Chandrayaan-2 is a failure. I don't feel it's a failure. That's what I believe. Then what is the other question? What is in a rocket? I have already told. Uh, what is the farthest humans have visited? So till now, we haven't visited Mars. We are planning to visit Mars in 2048. 40 or something like that. SpaceX and NASA has planned to send scientists to Mars, but till now we haven't it done. What are the, so see, you should use a lightweight materials in a spacecraft. So lightweight materials, if you don't use, your weight will become more heavier. Okay. And Chandrayaan-3, someone has asked for Chandrayaan-3. Chandrayaan-3 was a resounding success. It marked a major milestone in India's space exploration. It faced no major failures and performed flawless mission. Successful soft landing. Vikram lander made a historic soft landing on August 23, 2023. And the Pragyan rover successfully rolled out from the lander. So many things happened in Chandrayaan-2. So they learned lessons from Chandrayaan-2 and then they used that in Chandrayaan-3, and Chandrayaan-3 became a great success. So without any setbacks, without any major things, Chandrayaan-3 became a successful mission. Can migratory birds fly and go to space? This is who has asked that. Saidash has asked. So they cannot fly to space, but it's an interesting idea, right? Birds rely on air to fly, right? And they have to survive also. How will they survive if they don't have oxygen? Birds use gravity to glide and control their movement. So to leave the earth and reach space, they need to overcome gravity. So so that's why migratory birds cannot fly to space. Did scientists find water in another planet? They are telling that there is water, but still now it is not confirmed. They have found some underground sea in Jupiter, in one of the moons of the Jupiter, and so NASA is trying to find out. Still not sure. People are trying to find out. Mars had water earlier. Mars had atmosphere earlier, but because of the less magnetic field is very small in Mars, and because of that, right now there is no water, there is no atmosphere much. Let me go to Mars mission and then come back to the remaining questions because of the lack of time. So Earth to Mars missions. Okay, we have studied about Earth to Moon till now. We haven't studied, we have to study about Earth to Mars mission. Did you know that a day on Mars is just 40 minutes longer than a day on Earth? So this is almost similar. If you could travel to Mars, what would you like to do there? You can write there. What would you like to do? So Mars is known as a red planet because of the iron oxide on its surface. It is, if you look at the Mars, it looks red because it has a lot of iron oxide on its surface. And it has the largest volcano on the solar system. It's called as Olympus Mons. Its atmosphere is mostly carbon dioxide, so humans cannot breathe there. Scientists are excited because there was evidence of water and frozen form. So they are thinking that Mars could have once upon a time supported life. So why do you think scientists want to explore Mars? Mars might have had microbial life in the past. So scientists are thinking maybe it will help us to understand if there is life, or we can have it as a second home some other day. If we develop a good habitat in Mars, we can make it as a second home. So, so what are the key Mars missions? In 1970s, Viking mission was the first successful landers on the Mars. It searched for life but found nothing. Then 2004, we sent Spirit and then Opportunity like in a short time. And they explored Mars geology and found evidence of past water. Earlier, there was water like. And Curiosity 2012, we sent. It found more clues about Mars habitability. And Perseverance rover is the one which we have sent recently. I'll show you a video about it. It's searching for signs of ancient life. It's collecting samples to send back to Earth. So there is a helicopter also which was sent to Mars. It was called this Ingenuity helicopter. And in future, as I said, NASA and SpaceX are working on plans to send humans to Mars in another 10 years or something like that. You know, Earth and Mars are in motion around the sun. So 26 months you have to wait. If you send a mission to Mars now, you have to wait for 26 months because see, when Earth, it takes almost 365 days to rotate around the sun. That is 1 year. But Mars takes almost double times of that. So in this side, if you see this distance between Earth and Mars is too long. But in this place, it is short. So whenever our Earth rotates and come to this position, we are supposed to send mission to Mars. If we send at this place, we need to spend for a longer distance and you need lot of fuel. So we need to send at this point. So this is the Perseverance rover, which has gone to the Mars. And before that, as I said, Sojourner, Spirit, Opportunity, and Curiosity rover, all these things were sent. And Perseverance is the one which was sent recently. If you see the sizes, Perseverance is the biggest one. So how it is sent? It's kept like this inside a capsule sort. And then it's loaded into the payload and it becomes the top portion in the spacecraft, in the rocket. So like last time for Moon also we saw the astronauts were sitting on the top portion. The same manner because the bottom portions are just to give thrust. So you see here the rover is the most important thing like the astronaut. So rover is sitting inside and that it's supposed to land there. So now you have the first part. Perseverance rover was taken by Atlas V. Atlas V was the rocket that launched the Perseverance rover. It was launched on July 30th, 2020. And on February 18th, 2021, it landed. So think about it. July 30th, 2020, it was launched and February 18th, 2021. So almost 6 months it was traveling from Earth to Mars. So, so now you see it took around $2.5 billion. And you can see here the distance, whatever I said, Earth orbit and Mars orbit. So Earth is rotating around the sun. So it takes 1 year to rotate, let's assume. But Mars takes almost 2 years. So the distance between Earth and Mars, at one point, it becomes very short. So that is the launch window. So you can see here, this is the launch window. So we have to wait for the launch window. The first one is called the solid booster. So the 4 solid rocket booster used all the fuel in just 2 minutes. Then the main booster took it up for the next 4 minutes. And then that also fell down. So then finally the main engine boosted. The main engine had fired and that took the thing into the orbit. Within 8 minutes, it has to escape. It has to get out of the Earth's orbit and move towards the Mars. So these are the 5 portions. This is the heat shield, and you need a heat shield when you enter into any atmosphere. The heat shield will burn so much so that you will be protected. So they have finally entered into the Mars gravity, and now they are rotating around the Mars. And at one point, the rover launches the parachute, and the rover lands on Mars. This is the Perseverance rover, which has landed safely on Mars, and it is taking a lot of videos and sending information about Mars to us. So finally, let's come to the last thing. What do you think are the hardest things about exploring Mars? Mars is about 225 million kilometers away from the Earth. So that is why signals take about 22 minutes to travel each way. If a person gets into problem, it almost get the reply, we need 22 minutes to travel. So that is because in moon, when we saw in moon, it just take 2.5 seconds. 2.5 seconds, here it is 22 minutes. So also dust storms, extreme cold and low air pressure and safe landing. So many things have to be taken care. So now finally, the last question, what you want to discover on Mars? Do you think humans will live on Mars someday? Can you reply this? What would you like to discover on Mars? What do you think Mars should have? And will humans be able to live on Mars? So with this, I am open to questions for next 10 minutes. So somebody has asked, is it possible that there are other universes? Because of string theory and some mathematical things which gives higher dimensions. There are 22 dimensions. There are 11 dimensions. Because of that, they imagine. It's a hypothesis. It's not a proved fact. So we are not sure. This universe itself, we are not knowing how to explore, right? So it is, it's not that easy to explore if it is so many other universes are there. So it's a hypothesis. So we will not be able to get it. And the next question is, somebody has asked about, we can travel Mach 2 faster than sound. You know, Mach 1 is, what is Mach 1? Mach number is equivalent, Mach 1 is equivalent to speed of sound. So it's called as breaking the sound barrier. When an object reaches Mach 1, it creates a shock wave. That's why if you're going in an aircraft and you cross that sound barrier, you can get a sonic boom, a loud explosion like sound heard. So slower than the speed of sound is called subsonic, and around Mach 1 is called transonic, and Mach 1 to 5 is called supersonic. And hypersonic is more than Mach 5, extremely fast speeds. So passenger jet and all jets all go in subsonic. Supersonic, that is between Mach 1 to 5, you have the Concorde and other spacecraft. Space shuttles go at hypersonic speed, greater than Mach 5. So Mach 1, the speed of sound is 343 meters per second at sea level. So that is what is Mach stands for. Why is sun going to be a red giant? Because once after 5 billion years, when the sun dies, the mass is not that so huge to become a black hole. So it becomes a red giant. Lot of questions. Great. You are all so much interested. It's full of questions. What fuel they use? There are 3 main types, I would say. Liquid propellants or solid propellants. And then the third one is hybrid propellants. It can use solid with a liquid or gaseous oxidizer. So now let's come to the liquid propellant. Liquid propellant has like liquid hydrogen. SpaceX Falcon uses liquid hydrogen. What is advantage is it has a high efficiency, but the engine becomes very complex. Solid propellants are also mixed with oxidizer. Its powdered metals like aluminum and others become the fuel. And it is used in many of the space shuttle missiles like ICBMs, they use it. And hybrid propellants also use both solids and liquids. And so that is all about the propellants. So can we go to the Mars moon? A Mars moon are named as Phobos and Deimos. It's theoretically possible, but first of all, let's go to Mars. It's a good question that I would like to answer. When moon revolves Earth once in 27.5 days, won't it come in a line with sun and Earth at least once? In that case, why do we face eclipse? The reason we don't experience a solar or lunar eclipse every time the moon completes its orbit around Earth is due to the tilt of the moon's orbital plane. Okay, so the moon's orbit is tilted. So moon's orbit around Earth is tilted by around 5 degrees relative to the Earth's orbital plane. This means that moon passes above or below the sun-Earth line during its orbit. So eclipse happens only at the nodes. The nodes are the 2 points where the moon's orbit intersects the ecliptic plane. So that is why solar eclipse when the moon is between the Earth and the sun. Lunar eclipse is when the Earth is between the sun and the moon. So that is why every time it crosses, it doesn't give because of the tilt. It's tilted by 5 degrees. So how many eclipses, if you think, happen per year? There are around 2 to 5 eclipses, solar and lunar eclipse combined, if you see, depending on the alignment of the nodes. We don't have eclipse every month because, again, the moon's orbit is tilted. So this is a good question. I'm not able to see any more questions, but anyhow, I'll try to answer this raining. 2-3 people have asked about raining diamonds. So they say Neptune and Uranus alone, because of their extreme atmospheric conditions, they say that. Because it's called as the ice giants, Uranus and Neptune. They say that it is diamond rain is theoretized to occur. So because of the composition of the atmosphere, it's rich in methane, hydrogen, and helium. So because of methane, these Uranus and this one gets a blue color, and they have also extreme pressure and temperature. So the extreme pressure and temperature, methane molecules can be broken and release carbon atoms. So the carbon combine and compress and they become diamonds. So that is why these diamonds form in the atmosphere and sink deeper into the planet. And that's why they say that it's diamond raining. But I don't know because we haven't visited there because of the methane rich thing and the extreme pressure and temperature. They say that diamond rain is a result of extreme pressure and temperature. That's all, turning carbon into diamonds that fall like raindrops. It's one of the many fascinating exotic phenomena. How methane is turned into carbon is because of the lightning storms and others. So now you see lightning storms turn methane into carbon, and the extreme pressure and temperature turn carbon into compresses into diamonds. And that's why it's for raining diamonds. Carbon. Do we see into the past when we see the stars? Yes. When we look at the stars, when we look at the galaxies, we see how many years before, how many billion years before they were formed. So they give an idea about the universe, when it was formed and others. You know, somebody has asked, why is Uranus colder than Neptune? The primary reason Uranus is colder than Neptune is because it doesn't have an internal heat. Maybe this is a combination. Scientists are not sure, but it has a lack of internal heat. Maybe a past catastrophic event like something would have played that Uranus' internal processes make it the coldest planet. So that's also a good question. Neptune is far away, but Uranus is the coldest planet because it lacks internal heat. So what is the greenhouse effect on Venus? Okay, the greenhouse effect on Venus is an extreme version of the process that warms Earth. We have a greenhouse gases, right? Because of that, we have a warm temperature. So this is making Venus the hottest planet in the solar system, though Mercury is the closest one to the sun. Venus is the hottest planet because the planet's atmosphere traps heat from the sun. So that is why the heat doesn't escape back into space. So this effect is amplified because of the thick atmosphere. So Venus is the hottest planet, though Mercury is closest to the sun. I am just unmuting everyone so you can.
Ma'am, ma'am.
Um, Madam, I would like to thank you so much for this amazing session. Students, I hope you would have all enjoyed, though it's a short session, but I think she has covered maximum of the content. And I would like to thank all the students, participants, and the parents who have encouraged, and the students and who have patiently witnessed and taken a great insight on this the first the series of webinar series on aerospace.